right, this is lesson 4-5, part 2. We're going to continue on with our little shortcuts to proving triangles congruent. So we just talked about ASA, the angle side angle theorem. Now we're going to talk about the angle side theorem, AAS. All right, if two angles and a non-included side of a triangle are congruent to the corresponding angles and non-included side of another triangle, then we know those two triangles are congruent, right? So let's look at this example up here. I wish I could zoom in when I was doing this, but I don't. Oh, I can. Awesome. Yay. I'm going to read it to you and you can look at the picture. It's easier to see that way. All right, so it says, example, in the diagram, angle BCA is congruent to DCA, and it's already marked here. Which sides are congruent and what additional pair of corresponding parts needs to be congruent for the triangles to be congruent by the AAS theorem? Okay, so out of these two triangles, I need two angles and a side congruent. I only have angles proving congruent right now. What else do I know for a fact? I know both triangles share this line, AC. So whether it's used in this top triangle or whether it's used in this bottom triangle, it's the same size, right? So both triangles have at least one side that's the same size. So I can say, it said which sides are congruent? AC is congruent to AC. And then it says which additional parts need to be congruent. Well, I've got an angle and a side. Now, if I proved this angle congruent, if I said angle 1 and angle 2 are congruent, then I would have angle, side, angle. But I don't want angle, side, angle for this lesson. I want angle, angle, side, right? So this side that's congruent cannot be in between my two congruent angles. So this cannot be one of my congruent angles. So the only other angle left, there's 3 of them. I already marked one congruent. I need to mark one more, and it can't be this one, so it has to be angle B. Angle B has to be congruent to angle D. So I'm going to say angle B congruent to angle D. If these angles are congruent, if I said this guy is congruent to this guy, then I've got angle, angle, side, right? If I kind of drew out just one of these, I've got this angle, and this side congruent. And that's what I want for AAS. I want two angles and then another side that's not in between those two angles. Here's my two angles. The side between them is not the one that's congruent. It's this other one here. I could have also marked this guy congruent, right? Now, I don't know for a fact in this picture that this side is congruent to this side. I do know for a fact that both triangles share this side, so I know for a fact it's the same, right? So that's the only thing I can say, but it cannot be in between my two angles to use AAS. So hopefully that's making sense to you guys so far. Let's do a 2-column proof. I'm gonna back up just a little bit. All right, so based on this information, I'm gonna read it off. Here's the picture. Not good spacing, sorry. All right, so based on the given for our proof, it says BC is parallel to EF, and it's marked parallel here, with those little arrows. AB is congruent to DE, so this guy is congruent to this guy. This line here on this triangle is congruent to this line here on this triangle. And angle C is congruent to angle F. So here's angle F, here's angle C. Okay, so I have to prove that this top triangle is congruent to this bottom triangle. That's my goal right here, to prove these congruent, okay? So what did it tell me in the beginning? It told me two congruency statements, this guy and this guy, this guy and this guy, and it told me AB and, sorry, not AB, BC and EF are parallel. So how can I use that? Well, these two parallel lines are being cut by this transversal. I kind of highlight it, maybe it's easier to see. This guy and this guy. These are our parallel lines. They're being cut by this transversal here, right? So I know this angle, it looks like a 90-degree angle, but I don't know that for sure. But I do know that these two are going to be congruent because they are corresponding angles, right? So now I've got an angle, and a side that's not between those two angles, congruent to an angle, and a side that's not between the two, right? So these two triangles are congruent because of the AAS rule. So let's write that out in our little 2-column proof here. And then we're going to do a flow proof. statement, reasons, 1 given BC parallel to EF, AB is congruent to DE, and angle C is congruent to angle F. Okay, that's step 1. So there's 3 pieces, right? But only 2 of those are congruency statements. I got to have at least 3 congruency statements. And if I'm using AAS here, right, because that's the one I just learned, so I know I'm using this one, I proved a side and an angle congruent. So I'm looking for, I got a side, I got an angle, I'm looking for another angle, right? And that's when I use the parallel information to say these corresponding angles are congruent. So I'm going to say angle ABC is congruent to angle, and on the bottom it's DEF, because of my corresponding angles postulate. When I have parallel lines cut by a transversal, any corresponding angles are congruent. Okay, so then I have my 3 congruency statements. That's enough when I'm looking at my picture to know my 2 triangles are congruent because of the AAS rule. So step 3, I'm going to say triangle ABC is congruent to triangle DEF. Why? Because of the AAS rule. Hopefully that makes sense. 2 angles and a side that's not between them have to be congruent. Okay, so here's the fun part. Here's a flow proof down here. And they're all the same. I only have 1 example here. It helps the more examples you see. We're basically, again, doing the same thing as a 2-column proof. It's just set up really different. So instead of having lines, we're going to have boxes. And we work from the left to the right instead of top to bottom, okay? So every statement is going to go in a box, and the reasons are going to go below the box. So I'm going to start with my given. So we got 1 box here. Statement is angle S is congruent to angle U. And the reason is because it's given, so I'm going to put given. Each statement gets its own box. We got another box here. TR bisects STU. TR bisects angle STU. And that's also given, so you write the reason below it. Okay, so now we've got to go this way. And our goal is to make it sort of look like a triangle. We want to whittle it down to 1 box, right? Okay, so what else do I know? Here's a congruency statement. I need at least 3 of them, so this isn't going to do it on its own. I need to come up with something based off of this guy, so I'm going to draw an arrow. And I'm going to draw another box. What do I know about this picture up here based off of this given information? S and U are parallel. TR bisects STU, angle STU. So that tells me this angle up here is congruent to this angle down here, right? So I can say angle STR is congruent to angle RTU. And the reason goes below here, definition of angle bisector. Definition of angle bisector. When I finish this, it should make more sense, okay? So now I've got another congruency statement. So I've got my 2 things here. I still need a 3rd congruency statement, right? I'm going to try and prove that these 2 triangles are congruent, and then once I know that everything about the triangles are congruent, then I can name any other congruent parts inside. Okay, so what's the one thing I have that I know for a fact is the same here that's not listed? What about TR is congruent to itself? TR is congruent to TR, right? So I'm going to say, now that doesn't depend on this. That fact is on its own. So I can either put it underneath this column or I can put it underneath this column. Doesn't really matter which column it goes under. It just needs its own box and it's not coming from anything. So I can just say that RT is congruent to RT, and the reason is the reflexive property, right? So now I've got my 3 statements. So all of those statements help me prove one thing, and that is that my 2 triangles are congruent. So I'm going to draw an arrow here, and an arrow here. Okay, this is why this is called a flow chart, right? We start on the left, we just keep making kind of columns of boxes, right? This didn't need anything to help it out. This directly impacts what we're trying to prove. This is one of the three statements we need to prove our triangles are congruent. Triangle SRT is congruent to triangle URT, right? This guy did not directly affect this. Based on the fact that TR bisects this angle, I know it broke it into two smaller congruent angles. So this box tells me this, and this statement directly affects. This is one of my two congruency statements so far. And then my third congruency statement isn't related to these other boxes at all. So it doesn't have any arrows connecting them. It's over here on its own, right? RT is congruent to RT. That's its own thing. Points here. So now I've got these three congruency statements that tell me my triangles are congruent because of why? Well, I've got a side, an angle, but this side is not in between these two angles, right? So I've got two angles and a non-included side congruent to two angles and a non-included side. So that's the AAS rule, AAS. That tells me that my triangles are congruent, but that's not what I'm looking for. I want to say that angle SRT, which is this guy right here, is congruent to URT, which is this guy right here. That's super random, right? Like, where does that come from? How do I know that they're congruent? Well, I couldn't really prove it with anything, but I could go ahead and prove. This is supposed to be an arrow, if you're wondering what letter that is. It's supposed to just be an arrow pointing to this angle right here. These are the two angles we're trying to prove congruent at R. This guy here and this guy. Okay, I can't just come up with that on my own, that they're congruent, I don't know. But I did have enough information to prove that this entire triangle is congruent to this entire triangle. When triangles are congruent, that means all of their corresponding parts are congruent, right? So then naturally, this angle has to be congruent to this angle because they're corresponding angles in two different triangles. Okay, so backing up here, once I say that my triangles are congruent, based on that fact, I can come up with one more box here that says angle SRT is congruent to angle URT. And what's the reason? Cpctc. Cpctc. Okay, so I know that I told you before that Cpctc is the rule that we use whenever we've proven all 6 parts of two triangles are congruent. That is true. Whenever we prove, not using one of the shortcuts, whenever we do it the long way, and we show that all 3 sets of angles of one triangle are congruent to all 3 sets of the other triangle, and that all 3 sides of one triangle are all congruent to the corresponding sides in another triangle, then we can say the triangles are congruent because of Cpctc. Another time that we use Cpctc is whenever we prove triangles are congruent and then say that parts of that triangle are congruent. Anytime we've already proven that the two triangles are congruent, anything that comes after that is always because of Cpctc. Think about it. If we prove that two triangles are congruent, right? We've already said that the two triangles are congruent, then any parts of those triangles after that fact are also going to be congruent, right? Because corresponding parts of congruent triangles. Here, if I've already proven the triangles are congruent, I've got this middle part taken care of. So I'm focused on the first part, corresponding parts, right? If I've already proven the congruent triangles, then I want to look at the corresponding parts, and I know they're also congruent. Corresponding parts of congruent triangles are congruent. So I've already proven these two triangles are congruent up here. So if I'm looking at corresponding parts of those triangles, angles SRT and URT, this guy here and this guy here, and I've already proven that this entire top triangle is congruent to this entire bottom triangle, then I know that this angle has to be congruent to this, because they're corresponding parts of both triangles. They're in the same position of each triangle, and all corresponding parts of congruent triangles are congruent. All right, I'm beating a dead horse here, but hopefully that makes sense. So in any proof or flow proof or paragraph proof, any time that you prove two triangles are congruent, and then you take it a step further and say that specific parts of those congruent triangles are also congruent, the rule is always Cpctc. Always. Any reason for anything you say after triangles are congruent, is always because of Cpctc. Okay, let's do one more flow proof. I wrote it out real quick. Let me back up here, just so you get extra practice, right? Just real quick, just kind of, I'll try and go through it quickly. All right, so I have this little, like, looks like a rectangle drawn, right, with this diagonal line here, and it says given PS is congruent to QR, so I can mark that's congruent to that, and PS is parallel to QR, so I'll put my little parallel symbols. Prove that PQ is congruent to SR. How the heck am I gonna, based on those two pieces of information, how do I prove that this guy is congruent to this guy? This whole side is congruent to this side. Well, knowing I've got two triangles here, looks like I'll be able to prove the triangles are congruent. And once I know the entire triangles are congruent, then anything after that I can say are congruent because of Cpctc, right? Okay, so here I'm gonna fill out my flow chart. And I've already drawn out what the boxes are gonna look like. Usually for you right now, the boxes will be drawn out and you just have to fill them in. We're not quite to the point yet where you can draw them all on your own yet. Okay, so if I'm proving this, I know that's gonna have to go here at the end, right? So I can go ahead and write that in. PQ is congruent to SR. I just don't know the reason yet, okay? So what am I looking at here? I've got two pieces of given information, so I'm gonna fill these into my first two boxes here. So first is PS is congruent to QR. That's not a good congruency thing. And remember, the reason always goes below the box, so the reason here is just given. And then I've got PS is parallel to QR. And the reason is because it's given. Okay. So in order to prove my triangles are congruent, because that's my goal right now, and then this will come after that, I need at least three congruency statements, right? And so far, I only have one. So based on the fact, so I have this one. Based on the fact that it tells me these two lines are parallel, how can I use that to my advantage, right? Well, the measure between this line and this transversal is going to be the same as the measure between this parallel line and the same transversal. So I can say these two angles are congruent because of the alternate interior angle theorem. These are alternate interior angles. They're in between two parallel lines, and they're on different sides of this transversal. So I'm going to say angle PSQ based on this fact right here. Anything that you come up with based on something they've already given you goes in the next box coming off of that, right? So based on this fact, I can then say that angle PSQ is congruent to this other guy, this angle PSQ is congruent to this guy, which is RQS, this guy, angle RQS. Why? Because they're alternate interior angles between parallel lines. So the alternate interior angle theorem. The reason always goes below the box. All right, great. Well, what the heck do I do now, right? I need three congruency statements. I've got one here and here, but I'm missing another one, right? So will it come off of this? No, I don't know what comes next, but I can come up with just a random statement on its own. I can say that SQ is congruent to itself, right? Because whether it's used in this top triangle or this bottom triangle, it's the same line segment. So it's the same size. So I know at least one side of this triangle is congruent to at least one side of this other triangle because it's the same side. So SQ equals itself. That doesn't come off of any of this. It's unrelated to all of this. So I'm going to write it down here. SQ is congruent to SQ. And anytime you write something is congruent or equal to itself, that's always reflexive. Okay, so now I've got three congruency statements. 1, 2, 3. That's enough to say that my two triangles are congruent. Why? I've got a side, an angle, and a side congruent to a side, an angle, and a side, right? So side, angle, side. So these two triangles are congruent because of side, angle, side. So I'm going to say triangle PSQ. Triangle PSQ is congruent to the other triangle, PSQ, RQS, we'll call it, RQS, And how did I know those two triangles were congruent? Because of side, angle, side. Because of the side, angle, side postulate. Okay, and once I say that two triangles are congruent, I can say any pieces of those triangles are congruent because of Cpctc. Makes sense? This is the goal here for all of these, is to prove two triangles are congruent. Then if we want to take it a step further and tack on another fun fact, the reason's always going to be Cpctc. I hope that helps, and let me know if you have questions.